So let's use a two-way table to think about these colorblindness in men and women. So some assumptions we have up front is that the probability of being a male, let's say that's 50%. Probability of being a female, let's say that's 50%. And then we have those other probabilities, that the probability of being colorblind if we have a male, that's 7%. Probability of being colorblind if someone's a female, that's the 0.4%, or 0.4%, excuse me, 0.04. So again, this is 50%, 50%, 0.4%, and 7%. And so I'm just going to set up a two-way table where I'll have males versus females, and then colorblind versus not colorblind. Maybe we'll call that color. Sometimes when we make these two-way tables, people will go out of 1,000 or out of 100 or out of 100,000. 100,000 is kind of popular because when death rates are given and birth rates, they're often out of 100,000 people. I think here it's sufficient to go off a total population of 1,000. So we'll also have some totals going on here. So when we set up a table based on two categorical variables like this, and we're looking at their counts or frequencies or relative frequencies, this is called a two-way table. So we started making these way back in section 2.1. So 1,000 people going on here, and I have males should be half of the population. So then I'm going to have 500 males, and I'm going to have 500 females. Now, thinking about what this means right here, colorblind if they're male, that means only look at the male population. 7% of the males, not 7% of the population, 7% of the males are colorblind. So now I got to figure out what's 7% of 500. I think it's around 35. And if you're having trouble with converting percents, one safe thing to do, and I may have mentioned this last week, is that remember the percent symbol, percent, literal per means divide, cent means 100. And if you look at the symbol here, that's the divide right there, and those are the two zeros for the 100. So just to be safe, you can take whatever number you're given and just divide by 100 and then do what you got to do from there. All right, so I'll do that one in just a second. Let's write down that there are 35 males out of 500 is 7% of males are colorblind. Females, so if I think about that 0.4%, just type 0.4, divide by 100 to deal with the percent symbol. And some calculators have a percent symbol that does that for you. And then here I want to multiply by the 500 females in my group. That gives me 2 of them. So I have 2 females. So let's see, 35 of the males out of 500 are colorblind. So that means the rest must not be colorblind. So if we subtract here, what are we going to get? We're going to get a 5, and then a 6, and then a 465. Double check, 5 and 5 is 10, carry the 1, 9, 10, yep, looks good. And then 2 out of the 500, so that's going to leave me 498 people, plus 2 gives me the 500, can see color, not colorblind. As far as the totals go then, colorblind in the population, regardless of male or female, should be 35 plus 2, or 37. And then as far as the colors go, what do we get? 8 and 5 is 3, carry the 1, 16, carry the 1, we get 963 there, and if we add those up, it better come out to 1,000, otherwise my arithmetic is not good. So 7, 3, carry the 1, 9, carry the 1, yep, that all adds up. So sometimes instead of kind of like puzzling through multiplying, adding, and subtracting percentages, we can often look at the table and figure stuff out. So I know that 7% of males are colorblind. Another question I could ask is what percent of colorblind people are male? Another way to state that is the probability that a person is male if they're colorblind. I'm sure there's many other variations there, but that is the probability that someone is male knowing they are colorblind. And anytime we have that kind of knowledge, right, this is our knowledge that changes everything. That is all we care about. So with this question here, all I care about are the colorblind people. So colorblind is in this row, so I only focus on that row. Okay, so in that row, I want to look at males. So there are 35 males out of 37 total that are colorblind. And so whatever 35 or 37 is, let's use a calculator on that to get a percent, because everything else is percents. 35 out of 37 gives me, let's see, 3 decimal places, 0.946. And I rounded there, so I'm gonna use a wavy equals, and 0.946 is really 94.6%. So there's a 94.6% chance that if you have a group of colorblind people randomly selected, that one of them is male. So most colorblind people are male, very few are female, right? And we kind of get that idea up there. So notice that's pretty different than up here, right? 7% of males are colorblind, but 94.6% of colorblind people are male. And again, often in the media, anytime they state a percentage, it's often something like this. And I'm wondering, which group are they talking about? Are they talking about all males or all colorblind people? And again, the way we use English, it's not always perfectly obvious. So anytime I hear stats in the news like that, I stop and think, what does that really mean? Sometimes I have to puzzle out a table like this to think about it, sometimes not. So two-way tables are really helpful for playing around with probabilities. Venn diagrams are helpful for playing around with probabilities also. Okay, new problem. Let's see, and I didn't actually answer all of Tammy's questions earlier, so let me look back at that. Pause